So, welcome to the talk on JUnit 5, from Lambda to Alpha and beyond. First up, just a bit about myself. My name is Sam Brannen. I'm a Spring and Java consultant at a company called SwiftMind in Zurich, Switzerland. And I've been a Java developer for several years now, so basically 17 to be exact, a bit more than that. I've been a core Spring framework committer since 2007, so since Spring 2.5. Back when I basically rewrote Spring's testing's integration support, all the annotation-based stuff, and I've been maintaining that ever since. In addition, I'm also a lead of the Swiss Spring user group in Switzerland there. And as you can tell, conference speaker, trainer as well. And last but not least, since last October, I've also been a core committer for JUnit 5. Out of curiosity, who had heard about JUnit 5 before they saw the title of the presentation? A few people? Okay. Maybe 20%. Who's actually used JUnit 5? Anyone tried it out? One person, maybe? Okay. Hopefully after this, those numbers will change. We'll get into that a bit more later on. Okay. My company in general, again, SwiftMind, experts in Spring and Enterprise Java in general, focusing on Spring, core Spring framework, Spring portfolio projects, also Java EE, software architecture, design, code reviews, this kind of stuff. And you find us in Zurich, Switzerland. We're willing to travel throughout Europe, obviously throughout the world if you want us to. And you can find us on Twitter as well. So before we move on, who's actually using Java 8? What percentage? All right, so good. That's about half, sounds good. Who's on Java 7? Fewer, okay. Java 6? Anybody still on Java 6? Okay, that's good because JUnit 5 is based on Java 8. So who writes tests? Yeah, hopefully, if you're not raising your hand, you should be ashamed. All right. Who uses something like TestEngine? Okay, maybe 5%. Spock, something like that. Groovy-based. Maybe a few more. And who uses a framework called JUnit? Yeah. JUnit 3, anybody still doing that? Test case, a few people maybe? No. JUnit 4, yeah. 4.12, maybe more recent versions. Okay, all right. So you're in the right place. Here to talk about JUnit. It is a Spring conference, so we'll get to a little bit about Spring and JUnit towards the end. The agenda, so first up, going to talk about why we even want a JUnit 5. We're going to talk about JUnit Lambda, so the campaign that got this all started. Then we'll talk about the roadmap, so where we're coming from, where we're going, and then we'll dive into JUnit 5, some more of the details. Won't have time to cover everything, but hopefully you'll get a good overview and be aware of some of the features and extension points that you can use on your own. So then at the end, feedback. I'll give you a bunch of links. One of the goals here is to actually basically raise awareness so that you know what JUnit 5 is, you know what the differences are, you know how to kind of get up and running. You can try it out on your own and then provide us feedback. We're still working on a milestone, first milestone, so there's actually plenty of time right now to get involved, submit pull requests, make recommendations, participate in discussions, and stuff like that. So hopefully you will be encouraged or feel encouraged to do so. So impetus for change. Why do we have a new version of JUnit? Who's totally happy, 100% happy with JUnit 4? One person? Okay, well, maybe I don't need to do any convincing. Anyway, drive through some of the points that we see as important, why we even got together to begin with. So JUnit 4 released a long time ago, a decade ago, in fact. A lot has changed since then. I like to say testing needs have matured, so people don't just write unit tests, people write integration tests, system tests, all sorts of tests. So with that, people's expectations have grown, so in terms of what they actually expect as a feature set from a testing framework. TestEngine actually has some more features, you could say, and JUnit 5 will basically change the landscape for the JUnit users. In terms of JUnit 4, modularity is kind of a big ball of mud, just the one big jar, and we'll see that visualized in a minute. Another point, more for the internals, is that the test discovery and execution are tightly coupled in JUnit, so there's no kind of separation of concerns in different modules and things like that. In terms of extensibility, something that's near and dear to me as the maintainer of Spring's integration testing support, in JUnit 4, there's a lot of room for improvement different ways that could be done, and we'll see how it's been done in JUnit 5. And let's not forget Java 8, right? So Java 8 brings lots of new opportunities with things like streams, optionals, and lambda expressions, right? So things you couldn't do built in with Java 5. So JUnit 4 supports Java 5, right? And JUnit 5 supports Java 8 and above. So in terms of modularity, there are, of course, packages, right? It's not exactly one gigantic ball of mud in JUnit 4. It's actually pretty decent. But there's only the one big JUnit jar. So if you want to use JUnit 4, you just get the JUnit jar. And what that ends up looking like, right? So it doesn't matter if you're an IDE or a build tool, you're going to be working with the jar. It's the same jar that you're going to be using if you're the test developer writing tests, or a testing framework, for example, like Spring on the side there, or something like a JUnit extension from some other third party. Everyone uses the same jar. Everyone gets their hands dirty working with the same jar. In terms of extensions, who knows that there are runners in JUnit 4? Most people, OK. So if you're here at a Spring conference, hopefully you know there's also a Spring runner. If not, we can talk about that later. Basically, the runner is the basic extension point from JUnit 4 since JUnit 4.0. It is, in fact, very powerful. Why is it very powerful? It's powerful because it can do anything, but basically because you have to write everything. You can, of course, extend one of the existing ones, but it's kind of an all-in-one package there. But the biggest downside is you cannot combine runners. It's physically impossible, unless, of course, you write some kind of composite delegating runner, which some people have done, but that's normally not the case. So you can say @runWith, this is the runner that I want. So case in point, a lot of people over the years have wanted to use things like the parameterized runner from JUnit to have parameterized tests, and then use another framework like Spring and have all the support from Spring and have them at the same time. But that's physically impossible with the basics of runners in JUnit 4. And this title here, you can read it 3 or 4 ways. You can say JUnit 4 rules, like it's cool. Or you could say rules are meant to be broken, which is kind of my joke. Or you can just say JUnit 4 rules are meant to be broken. I'd say it's all of the above, kind of mixed. So again, JUnit 4.0 introduced runners. And then a few years down the road, they realized maybe that's not the best way, can't combine them. So the team came up with the method rule in JUnit 4.7. And you can annotate a field with @rule for that. And that gives you access to basically the method, like right before the test method, as you might expect, kind of like a wrapping thing around that, or a chain of responsibility. And then in 4.9, they realized, OK, we need some kind of support for class-level stuff. So they introduced @class rule that you could use and a different interface there, @test rule. So they're making some progress there, but not the full picture. If you compare and contrast this with Spring's testing support, since JUnit 4.4, we already had support for all these kind of callbacks way back then. So the JUnit team was catching up with some third-party stuff like Spring. So these are great for simple use cases, common use cases, expected exception, timed, something like that. And you can combine them. You could come up with your own kind of a chain rule or something to combine them however you wanted to. But, and this is a real downside for a testing framework that's more powerful like Spring, a single rule cannot be used for method level and class level callbacks at the same time. It's physically impossible because the JUnit guys said the one has to be static and the other one can't be static, and you can't implement the right or both interfaces at the same place. Anyway, it just doesn't work. Plus, there's zero support for what I call instance level callbacks. So we got this method level stuff and kind of the class level stuff, but nothing for right after the test instance is created. For example, where somebody like Juice or Spring would want to perform dependency injection. You could hack it in. I did that in JUnit 4 in the runner, also at the rules, but there's no first class support for that. So case in point, exactly there. I put off implementing rules in Spring for several years because it was never going to be elegant, and it never will be. But in the end, I gave in and said, OK, I'll do it. But I had to do it with two rules. So it's kind of ugly. You have to kind of copy and paste some code, declare the class rule and the method rule. Otherwise, you don't get the full support from Spring. So with these kind of things in mind, with JUnit 5, we said we definitely don't want to have this kind of ugly stuff. We want to make it easier. We want extensions to be able to implement any of the extension points that they want to, right? And provide functionality for all these different levels, method level, class level, instance level, et cetera. So that's kind of why JUnit Lambda came about. right? Some of these growing pains over the years with JUnit 4. And we have the crowdfunding campaign, JUnit Lambda as kind of the code name, Lambda coming from Lambda expressions with Java 8, right, is the impetus there. That was initiated by Johannes Link and Mark Phillip back in, well, last year, about a year ago. Later joined by Matthias Meredith, Stefan Bechtold, and myself later on last spring. And that ran from July to October 2015 for the actual fundraising part there. We raised a fair amount of money, so almost 54,000 euros from almost 500 individuals and companies. And in addition, 4 companies donated 6 weeks of senior developer time to actually get the whole thing off the ground and get some real work done. So that was basically what was needed over the years. There were definitely core committers for JUnit 4, but no one had the time to drive it forward and actually do a new release and start from scratch or anything like that. So thanks. If your name's up there or your company or one of the companies you know, there are definitely some people here from Pivotal, so you can all be proud in your companies that have contributed. What we did after we gathered the money, we started off with a kickoff last October in Karlsruhe, Germany. And you see some pretty big names up there. We had support from IDEs, right? So we had somebody from Gradle there, somebody from Eclipse, also somebody from IntelliJ. We wanted to get the build tools on board so they could voice their opinions about what JUnit 5 needed in order to be adopted by them. And then we had some other big names in the company, in the community, American Express and Pivotal. Maybe Oliver Gierke is even here. He's on the picture up there. But basically, so we met for a week and discussed what do we want to do. Do we want to do Java 6? Do we want to do Java 8? Do we want to start from scratch? Do we want to build up Java 4? We ended up saying we're going Java 8, kind of like Spring 5. It's going to be JUnit 5, and yep, that's where we went with the prototype. So for the roadmap, we started work on the prototype right after that. We had snapshot releases up through the beginning of December where we tagged it, and then we started working on our first alpha, which we released. That's in Maven Central, so you can actually build against that with your Graven dependencies or Maven. That was February 1st. And since then, we've been working towards the first milestone, so that's in progress. If you see my tweets, you'll see that we have already over 2,000 commits to master, 19 contributors, and only 9 issues open for M1. So we hope to get that done by the end of this month, if all goes well. And over the course of the summer, we hope to have some other milestones out based on feedback we get from some of you, hopefully, as well. And then later on in the fall, basically pushing out some release candidates, and then hopefully a GA release by the end of the year if things go well. So, but we're now kind of all contributing in our free time. The crowdfunding campaign funds are dried up, but we're still working hard in our free time and hope to get this out by the end of the year. So, JUnit 5, in a nutshell, what is it? It's definitely modular, much more modular than JUnit 4 was. Extensible, so we'll talk about that a bit of detail. Modern, we like to think it's modern. It's at least based on Java 8. And it's what I like to call forward and backward compatible, which might sound a bit strange. JUnit 5 obviously can run JUnit 5. That's probably not a shocker. But JUnit 4 supports JUnit 3.8 and JUnit 4. So that means you can run JUnit 5 code, JUnit 3 code, and JUnit 4 code all in the same test suite, basically. And on the flip side, you can run JUnit 5 with JUnit 4. Might sound a bit crazy. Why would you want to have all these options? The reason is that basically we know people have existing test suites, hopefully not so much JUnit 3, but definitely JUnit 4. JUnit 4 knows how to run JUnit 3, so there's no real work on our part there. If we support JUnit 4, JUnit 3 comes with it out of the box like that. But right now, build tools and IDEs don't know how to run JUnit 5 tests. So the trick is you can use JUnit 4 to launch the JUnit 5 engine, and we'll see that with some demos later on. And that's actually what I do in the IDE. I use JUnit 4 so that Eclipse knows how to run my tests, and I see whether they're passing or not. And in the build, we actually run them straight up with JUnit 5. So for that, there is @runwith. Again, that's JUnit 4. And then we have this class called JUnit 5, which is an implementation of the JUnit 4 runner, right? So you're saying, using JUnit 4 in my IDE, but I actually want to use JUnit 5 programming model and extension model, etc. In terms of the architecture, we see we have quite a few more things here, in contrast to what we saw before with the one big JUnit 4 jar. So if we take a look here, we see we have this kind of engine API in the middle, and the launcher down here. And the IDEs and build tools, those are going to work with those. We also have a console runner that allows you to run that from the command line. And then we see on top, over on the right, we have JUnit 5 tests. So using the JUnit 5 programming model, test model, just depending on the JUnit 5 API, and behind the scenes using the JUnit 5 engine. So the way we support JUnit 5, JUnit 4, and JUnit 3 all at the same time is we just have other different engines. So again, your test code just depends on the JUnit 5 API. That's all it needs to compile. To actually execute, it has to have the JUnit 5 engine behind the scenes. And the IDEs and build tools, they're on the other side, right of the whole picture. They don't need to know so much about the API. They don't care so much. They just need to know about the launcher and the engine APIs there. So basically, we have this separation now between this kind of the discovery and the execution and how you write your tests, and allows the whole thing to be much more flexible, allows you to add on different engines over time, et cetera. So in terms of modules, just a brief overview. Again, the API, JUnit 5 API, that's going to be stuff like the annotations and assertions. The launcher, that's for the build tools, right? You can use it on your own if you want. If you have some kind of some kind of manual way you want to start up JUnit 5, you can do that. The engine API, that's if you want to implement your own engine. So some people are actually already looking into that. We'll see we have some already in place. The engine for JUnit 5, that's the first one. And the JUnit 4 engine, that's the one that knows how to run JUnit 4 tests and also transitively JUnit 3 tests. Then there's this JUnit 4 runner. We couldn't come up with a better name. This is the thing that contains the JUnit 5 implementation of the JUnit 4 runner interface. Anyway, if you come up with a better name, let us know. JUnit Commons, we have now extracted some of the common utilities so that we can use it in various parts of JUnit from now and in the future. And again, this console, there's a console runner. Even like Spring Boot does some color-coded, not really ASCII art, but different colors for success, failure, and skip, and that kind of stuff. In terms of build support, right? So we had Gradle there at the kickoff, and we had some IDE vendors as well. But we want to make sure people could start using it today, right? So we've introduced our own Gradle plugin and our own Surefire and Maven plugin that support JUnit 5. We hope that we do not have to maintain them over time, and we hope that the respective parties will pick these up and do it the right way, the professional way. But for the time being, you can actually run your JUnit 5 tests with Gradle or with Maven, and we actually build JUnit 5 and test it with JUnit 5 and Gradle. So this launcher API, as you'd expect, this is used to launch the framework, and that's used by the IDEs and the build tools. This is the central API for both discovering and executing the tests via one or more engines that are kind of picked up dynamically. In order to tell JUnit what to run, you provide a test discovery request, basically saying like which classes, or which packages, and this kind of stuff, which tags, all this. And this is what's known as selectors and filters. So selectors is like saying, select these packages, select classes with this that match this regular expression, and filtering is stuff like filter out certain engines or filter out certain tags for this particular test run. Then feedback is going to be provided via a test execution listener API. And now if you know Spring's testing support, don't get confused. We have an interface with the exact same name, but they are not the same thing. Anyway, so the test execution listener API in JUnit is the way that build tools and IDEs get informed about what's happening with the test. Test it pass, test it fail, all this kind of stuff. Turn to this TestEngine API. You could say this is somewhat analogous to the runner from JUnit 4. This is the thing you want to implement if you really want to tie in your own new programming model for JUnit. We hope people won't need to do that too much. We hope that we have enough extension points in place and extension APIs people can implement, but you can actually implement your own. I've heard talk of someone interested in implementing a test engine, for example, for Kotlin support, so that could be kind of cool, something like that. So a test engine is responsible for discovering and executing tests, but limited to a particular programming model. So the JUnit 4 one knows how to find the JUnit 4 tests and JUnit 3 tests, and the JUnit 5 one only knows how to find the JUnit 5 tests. And that's why you can run them both at the same time. You can have them both discovered, and there's no overlap. So the JUnit 5 engine is going to ignore all the JUnit 4 stuff and the other way around. These things are picked up automatically. discovered automatically using Java's standard service loader mechanism, similar to Spring Factories, if you're familiar with that, used often in Spring Boot and things like that. So basically, just make sure the jar is in the class path and the engine is automatically going to be enabled. So out of the box right now, we have this JUnit 5 test engine and the JUnit 4 test engine, and as I mentioned, you are free to implement your own if you want to support something else, maybe something like Cucumber, Kotlin, whatever. The extension model. So in JUnit 5, we have, first up, new package name, right? So we see this org.junit.gen5, starting from there. And in JUnit 4, everything starts with org.junit as the base package. We've had long discussions, debates about what we should use as a base package. For the time being, we've gone with Gen 5 for 5th generation, Gen 5, Generation 5. And that allows us to make sure that we don't have any potential overlap with JUnit 4, even if there's a JUnit 4.13 or JUnit 4.20 or if, whatever they keep building there. We just want to make sure there's no collisions there. If you have a better idea for a name than Gen 5, let us know. We're willing to take suggestions there. But in general, everything that starts with org Gen 5 means that you're using the JUnit 5 new stuff. So instead of @runWith, like we have with JUnit 4, we see we have an @extendWith annotation. So with JUnit 5, again, the idea is you provide extensions. So the engines are there, and an engine can support multiple different types of extension APIs. In terms of the lifecycle, so the test lifecycle, we have several callbacks that one can choose to implement. And for example, Spring implements 4 out of 6 of these at the moment, the Spring extension. And this is what a colleague of mine has called indentation art, kind of like ASCII art. Just kind of give you a little visualization here. So we see at the top we have before all and then after all, right? It's kind of like a wrapping around that. The next level we have before each, after each, and then inside we have before test method and after test method. And then there's an invisible line there, and that's where the test itself would actually execute. So each of these is currently a functional interface in terms of Java 8, so you could potentially implement this as a lambda, something like that. And you can implement one of these, 2 of these, all of them, and JUnit 5 will basically invoke them at the right time. Next up, we have support for what we call conditional test execution. So this was kind of inspired, you could say, by Spring. Surprise, right? So there's @conditional in Spring, right? You have stuff like @profile or @conditional if this bean is there or not there, or if this thing's in the class path and stuff like that. So during the prototype, I brought up to the guys, it'd be nice if we implemented that in JUnit 5. So what we have is we have a container level and a test level. Container level is a generic term for example, a class. So that would be around your class, all the test methods in your class. And the test execution condition is whether or not an actual test method executes. So the nice thing about this, it's quite powerful. It's programmatic. You can implement this yourself. Typically, you'd probably want to do something like if the system property is this value, or if the environment variable is this value, then run the tests or don't run them. The funniest one I've seen so far was a guy who blogged and said, yeah, we have this flaky test, and I don't want to run it on Friday afternoon from 4 to 6 p.m. because I don't want my boss to make me stay. So he wrote a condition and said, if it's Friday afternoon and the time is 4 to 6 p.m., then just disable this test. So I'm not condoning that kind of condition, but it is powerful, and you can do whatever you like. We'll talk about later on disabled, and it'll make a bit more sense. Instance post-processor might sound familiar to Spring people. Anyone think of anything similar? Bean post-processors, right? So in JUnit 5, we have an instance post-processor, and that's this missing instance level callback that I said that was never there in JUnit 4, and that's a first-class citizen in JUnit 5. So frameworks like Spring and Juice can inject dependencies at the right place before any of the before methods and stuff like that. Next up, also inspired by Spring, who's ever used Spring MVC? Only half. Who knows about argument resolution? Yeah, so you can basically provide your own. So we borrowed this concept, and we had noticed anyway, with JUnit 4, right, you can't accept any parameters in a method, any arguments. But there were people who'd written their own custom runners, and we thought, well, it'd be nice if we supported that not only for JUnit to provide stuff like the test name, right, but maybe to provide some other stuff from another framework like Mockito could provide a mock, or Spring could inject a dependency or something like that. So we have a method parameter resolver API, which is again analogous to what you have in Spring MVC. And any extension can contribute here and provide their own. And we'll see later on in some demos that you can have stuff like JUnit, Mockito, Spring, all providing parameters to your methods at the same time. I think that's a pretty cool feature, and we're interested to see how people end up actually using that over time. Next up, we have what's currently called the exception handler extension, and that allows you to basically handle an exception that's thrown during the test. So if it was expected, then you could basically swallow it. If it weren't, you could let it propagate, or you could log it, whatever. So this would be kind of like the analogous support for expected exception like you had with JUnit 4. Next up, the JUnit 5 programming model. So this is in the org JUnit Gen 5 API package, and it has several annotations. So first up, annotations and meta annotations. I just point out we do support meta annotations, also inspired somewhat by Spring, you might say. It works out very nicely in the end, actually, because in the past you could never use the @run with annotation from JUnit 4 as a meta annotation. So you always had to declare @run with Spring JUnit 4 class runner.class. Right? It was quite annoying, and with JUnit 5 and Spring, that's no longer an issue. You can declare that as a meta annotation and then kind of reduce your configuration. We also have support for assertions and assumptions, custom display names, so something new in JUnit 5, not just the standard name like the name of the method or the class. You can provide something custom. Visibility. Oliver Gierke, I don't know if he's here, but I liked one thing he said at the kickoff. He's like, let's not be stubborn, right? So we're using reflection, don't make things or require things to be public, and we took his advice. We liked it anyway. So you don't have to have public classes or public methods. They just can't be private. But basically, you can type less with JUnit 5. We have first-class support for tagging. There were the experimental categories in JUnit 4, but we'll see some examples of tagging. I already talked about conditional test execution, as well as dependency injection for these methods. And in certain places, we also already support lambda expressions and method references for things like assertions, expected exceptions, these kind of things, and also upcoming programming models for dynamic tests. Another nice thing Jürgen was talking about in his previous talk is default methods on interfaces with Java 8, using that with Spring configuration. It turns out you can also use that nicely with testing. We'll talk about that as well. Nested test classes, something completely new. There were some custom runners with JUnit 4 for that, and now that's a first-class citizen of the JUnit 5 programming model. So in terms of annotations, we have an @test annotation. I know you're all really surprised by that, right? We thought about it. We couldn't come up with a better name, and that's what we stuck with. One thing that's different from JUnit 4, we don't accept any attributes here. So these are just all standard annotations. Use them as is. Before all and after all, we decided we want to support things potentially not tied exactly to the programming model you know well from JUnit 4. We'll talk about later on scenario tests and these kind of things. So instead of saying before class and before, in JUnit 5, we've called them @before all and @after all, because it means before all and after all of the things in this current container. They might be tests, they might be steps, something like that. And after that, instead of having @before and @after, like in JUnit 4, we have @before each and @after each. That takes care of the life cycle, basically. @displayName is how you provide a custom display name. Tags, straightforward. There's an @tag annotation. And @disabled is basically analogous to @ignored in JUnit 4. But in JUnit 5, when we talk about conditional tests, we say tests are either enabled by default or disabled because of the result of evaluating some condition. And then this @nested annotation as well. So assertions, we actually debated whether we should support them at all. In the end, we decided we'd go for a basic set. So we do have things like assert equals, assert not null, assert same, these kind of things. We're currently adding in support for assert array equals and things like that. But we also have some cooler stuff that weren't in JUnit 4, might come in JUnit 4.13. Assert throws and expect throws. So basically you can provide a method reference or a lambda expression and JUnit will catch the exception for you and then give you back a reference to it, right? So you don't have to write an ugly try-catch block. And this is basically what we think people will tend to use instead of stuff like the expected exception rule from JUnit 4. Another cool feature, something we kind of borrowed from assert.j. Basically, you want to assert multiple assertions, but not have the first one fail your test immediately. Maybe you're, I don't know, testing all of your setters and getters in one thing, and you want to make sure that the get first name works and the get last name and all that. And you say assert each one as separate ones, and it will basically provide a list of all of the failures in one multiple failures error. So it's kind of cool, but small feature there. Another thing, instead of just having strings, we have noticed at times that some people have rather complex error messages that they build up when their assertions fail, maybe string concatenation, maybe pulling some stuff that was lazily loaded and always executing that code. And when you want your tests to run fast, nice thing with Java 8, right? You can just provide a supplier of string, so you can have your own little lambda expression there inlined that only gets evaluated if the assertion actually fails. And another thing, the message is now the last parameter in the list. So don't get confused with that if you're upgrading or migrating. And if you need more power, don't talk to us. This is what we're offering, the basics. If you want more power, use something dedicated like Hamcrest or assert.j, much more powerful and more popular frameworks for specialized assertions. Assumptions. Who's actually ever used an assumption? 3 or 4 people? Not too many. OK, so an assumption means I assume that this is true or this is false. I assume some condition. And if it's not, then basically abort the test now, which means don't fail it, just kind of like skip it mid-flight. So we have that in the assumptions class, limited set of core assumptions there. Things like assume true and assume false, taking Boolean values and strings, or in Java 8-like, right? You can also provide a Boolean supplier or a supplier of string for your messages. Another small feature, somewhat analogous to an if block, but using lambda expressions. So you can say, assuming that this holds true, then I want to execute this bit of code that I'm providing as a lambda expression, and otherwise just kind of ignore it and continue the test. So that can be nice if you're checking something only on the CI server, for example. So now I will try to demo a bit here. All right. Is that visible? Yep. So if I wanted to start off with a new class, I'm going to do a little trick that I do. I'm going to use JUnit 4, like I said, and I'm going to tell it to run with JUnit 5. It seems a bit crazy. We have support for scanning for packages, so package scanning, and we could say basically this current package. And if I try to run that now, it's not going to be too exciting. But you see at the bottom, this logging, it found engines JUnit 5 and JUnit 4. So they're both in the class path. That means I can write tests with JUnit 4 or JUnit 5. So I'm going to start with a JUnit 4, JUnit 4 test. Something like that. This won't be too exciting. But pick the one from JUnit 4 and public void JUnit 4 test. I'm not going to assert anything. I'm just going to rerun the test and kind of show you what happens here. So we see now we have underneath the suite, we have this engine JUnit 4, and then we have what we'd expect from JUnit 4 anyway. So like the class and the method, and we can go back to it. If we wanted to do something similar for JUnit 5 tests, we could create a new one. And again, this doesn't have to be public, right? So we could just say tests, and we could say test, but pick the right one, right? So this is in the Gen 5 package because it's a JUnit 5 test. Void doesn't have to be public, so JUnit 5 test, right? And now if I rerun the test suite, we'll see I have both, right? So both the engines are running their respective tests. JUnit 5 test, that's there. We can even navigate back. I did have a person ask once, can you write JUnit 4 and JUnit 5 methods in the same class? And you can. I wouldn't recommend it, but it does actually work. So if you let's be more explicit. Say something like org.JUnit, yeah, like that. And then this one, yeah, maybe be very explicit. So in theory, I haven't tried this, but it should run them both. So we should have it duplicated. So the JUnit 4 is there, and the JUnit 5, we see it got, both those methods got run, right? And the JUnit 4 went in JUnit 5. You could do that. Maybe as a migration step, you might want to. I wouldn't highly recommend that, but that does, in fact, work. Some other things we saw, so we talked about, did we get to display names yet? Let's see. Just a second. So assertions before each, right? So again, if you want to have befores and stuff like that, that's quite easy. Before each, you can do that, right? That doesn't have to be public either, so avoid before each. I'm not sure why that made it capital. So we see that's hopefully outputting something as well. So basically, when you look at the simple tests, it's going to be like in JUnit 4. You have the same constructs. You have @test annotations for your methods. You have these before each and after each for your before setup and this kind of stuff. And you can run JUnit 4 and JUnit 5 in the same test suite in your IDE, or have everything aggregated in your results, your reports for your testing. So that's some of the basics there. Okay, in terms of test names, so as we know from the past, kind of like with JUnit 4, names are going to default to the test class or the test method name. But those are, of course, going to be limited based on Java syntax. So what's valid there is what you can use in your name. But sometimes that's not as expressed as you would like for it to be. Maybe you end up using a lot of underscores. You'd like to use some other syntax, colons, and stuff like that. So with JUnit 5, you can have custom names with the @display name annotation. You can have spaces in them, special characters, and even, yes, emoji. That's maybe the most liked feature in JUnit 5. That was not intentional, by the way. We did never have that as a requirement, but after I implemented, I was like, I wonder if you can use emoji, and you can. So, dependency ingestions, I mentioned that before. This is basically where the extension model meets the programming model, right? So some extension has to provide something to be injected, but you have to know how to configure that with your test methods. Again, there's this method parameter resolver extension that can be implemented to do that. Out of the box, we have support for test info. This is somewhat like test name from JUnit 4, but it provides information for the name, the display name, and whatever tags had been declared via the @tag annotation. A nice thing about this is you can use this not only on the test method, you can use it on an @before each, an @after each, or before all, after all. You can always get access to the test info. That's quite nice. And to implement this, we have the test info parameter resolver, which is our first example of eating your own dog food, right? So it was one of the key goals we had. We didn't want to implement stuff that only JUnit 5 could do. We figured if JUnit 5 needs to be able to do something, then other extension writers probably need to be able to do the same thing. So we just open it up and make it an API anyone can implement, and we use the same extension and just implement it ourselves. You can see also test reporter for providing dynamic information about your test if you want to include it in your XML reports, for example. We have an example Mockito extension, which, for example, allows you to inject the mock that you want to prepare, maybe modify it in the before, and then use it in a test method. And, of course, the Spring extension uses this for injecting dependencies from your Spring application context, and we'll see some examples of that later on. So just very quickly with the names there, what's possible. So here we have this JUnit 5 test. I'm going to cheat a little bit. I just want to run this one class. So you can also just run a particular class. The only drawback is JUnit 4 requires it to be public. Otherwise, it won't run it. But now if I run just this class, it should run, right? So we got this JUnit 5 demos, and JUnit 5 test. But what if I don't like that? What if I want to say display name and say my first? If I could type JUnit 5 test. Cool, huh? So if I want to run that, then we should see that as well, right? So that's listed. Unfortunately, IDEs don't know about that, so if you double-click on that, it's going to say, we don't know a method named my, but, right? So we hope that's going to come in the future. As I talked about with the, if I can maybe type some kind of emoji here. Can't type it in the IDE, but I could do something cool like sunglasses, and then go back and, yes, who thinks it's going to show up? Is the emoji there? There it is. All right. Woo! Yeah. So, like I said, everyone loves emoji. I could use that icon that Phil used during the keynote, but I'm going to refrain from that for the moment. So, to show you the test info support, you can also use that. So if you wanted to print out the test info, for example, you'll see it has the name, display name, and the tags. So now if we go back to the console, we see that. That's exactly this test info as I mentioned. So it had the name there, that was the method, right? The display name there, that was the one we just used. The tags, it's not annotated with any tags, so they don't show up. But you could, for example, use this in some kind of reporting utility you have or whatever you need if you need something based on the name. Okay. So this goes to 1820, right? Is that right? Something like that. Tagging, next up, right? So you just declare basically @tag or @tags. @tag is a repeated annotation in the sense of Java 8. So you can tag a class or an individual method. Here we have an example with @tag fast and @test. So we're saying this is a fast test. By default, the tags are actually ignored. What that means is that all tags are included by default. You can, however, configure the launcher, and we assume in the future with the IDE, et cetera, that you could say require these particular tags or exclude these particular tags. And we also have support for requiring and excluding with this test suite support I showed you for the JUnit 5 runner for JUnit 4, and also with the Gradle plugin. So that'll be coming in the future, ways to set that. But in any case, once you have something like that, if you say I only want to run the fast tests, it'll pick all the fast tests in your suite. In terms of custom tags, this is where you have the support for meta annotations and making use of that in our own code. So you can declare @tag on your own custom annotation, your own composed annotation, kind of like what Jürgen was talking about earlier for Course Spring. You can do that to a somewhat similar degree or to a lesser degree with JUnit. So here we have our own @fasttest annotation. We're saying it can only be declared on methods, and it is annotated with @tag fast, like we saw in the previous slide, and it's also annotated with @test. So if we want to basically look at the previous slide where we have these two lines, right, we can reduce that to one in our own custom declaration, so we can use this @fasttest annotation across our code base. Maybe you have fast tests, smoke tests, unit tests, integration tests, CI server tests, these kind of things. If you'd like to control that via tagging, you can do that, and you can even declare more than one tag. So you could have like fast smoke tests or any kind of combination you want like that. In terms of this conditional test execution, again, this is another place where the extension model meets the programming model. So some extension provides it, and you set it up to use. Again, these two types we talked about before. @disabled, again, that's basically @ignored, but in JUnit 5. And we have our own implementation of a condition there. It implements both of these APIs. So @disabled can be used at the container level, meaning like at the class level, or at the method level. And that's, again, another place where we're eating our own dog food, right? So we didn't provide baked-in support like for @ignored with JUnit 4. We said this is a generic concern that not only we need to implement, but also other people, so you can implement your own. And since a few days, I just recently added in support for deactivating this stuff. So maybe some of you know over time you've used @ignore, for example, in JUnit 4, all over the place for things that are broken, and you want to know, are these things really still broken? I don't know. Or maybe that one guy who's cheating and not running his tests on Friday afternoon, you want to see, does it really run? You can deactivate conditions. You can do that via a launcher configuration parameter or a JVM system property called JUnit conditions.deactivate. And then you can provide a pattern there, so you can say star, which matches everything, or a particular package pattern or class pattern, et cetera. Running a bit short on time, so I'm going to skip the example there with disabled. It's quickly talking about default methods. Cool thing here, right? This kind of introduces a new concept, what I like to call a test interface. Basically, as Jürgen was also mentioning earlier, it's a form of multiple inheritance in tests, right? So you can actually have behavior in your test interfaces, which is kind of like testing traits, if you prefer to see it like that. So which annotations can you use? Which parts of JUnit 5 can you use there? You can use at before each and after each, at test, at tag, at extend with. Those things all work fine when declared on an interface or default methods. Those are found. At before all and after all don't work because they're required to be on static methods currently, and you can't do that with the default methods in an interface. For example, I recommend you check out the user guide. We have examples of actually all of these features in action. It's all compiled code and executed code that we just include in the ASCII doc there, so it's guaranteed to work. And string tests is one example there for using default methods with interfaces in Java 8 and JUnit 5. Nested test classes, not really something everyone's going to need, but there are times you could need it. Basically, it enables logical, hierarchical grouping of your test classes with shared initialization for the outer instances and shared state from the outer instances as well. Basically, just declare @nested on not the top level one, but any of the non-static nested classes, which in other words is an inner class, right? So you can declare it like that. And you can even combine nested classes with interfaces and default methods and this kind of stuff. So you have some new opportunities that didn't exist in the past. And again, here, for example, check out the user guide, specifically the testing a stack example. So it's a Spring conference. I have to talk a little bit about Spring, right? So in Spring, we had the Spring runner, right, basically for JUnit 4. Now we have a Spring extension for JUnit 5. And to use it, you just say @extend with Spring extension.class. It's really that simple, and you get the full support of the testing framework. So I have here a link where this thing currently resides. It's in my personal repo. That'll be moving into master for Spring 5 once Spring 5 becomes master. So people can start trying it out there. Currently, it works 100% with Spring Framework 4.3 snapshots, release candidates, etc. Maybe we might, potentially, if there's community interest, provide a standalone version that works with Spring Framework 4.3 in case you can't upgrade to Spring 5, but we'll be discussing that later. Basically, right now, it does pretty much everything. So all of the core features you have from the test context framework, the integration testing support from Spring, you can do that, use that now with Spring 4.3 snapshots and this extension. One of the cool things there, at least I find cool, opening some new doors, new opportunities. You can use @autowired, @qualifier, and @value on parameters passed into your test methods or your before each methods and stuff like that. You can also have your application context wired in. Maybe not that common, but more common with something like Spring MVC test, where you might want to wire in your web application context because you want to pass that off to the builder for your mock MVC instance. So that can be a very nice way to use the features of JUnit 5 and the Spring extension. And again, this will be fully integrated in Spring Framework 5.0, so full support for JUnit 5 with Spring 5. Now I will very briefly show that in action, I hope. So let's say we want a new class, Spring tests, and oops, hope we don't need that anymore. Extend with Spring extension .class, and if we add a method, the right one, I'm going to cheat again and run that with JUnit 5. So this is probably going to complain. Anyone know why it's going to complain? Because there's no application context, right? So that we at least see it should be working as long as we add in a configuration class. Okay, so now we have a configuration class. And if we run that, we'll see that it actually runs. Maybe we want to actually have some kind of bean in there just to see that it's really doing something. So we could say bean, and then let's say we want a cat, which is the type I have, and we're going to say catbird. So it looks like it all compiles. Okay, so we can hopefully auto-wire that in. Yeah, and if that's still working, then we see that works as well. So we could say assert equals and catbird cat get name. We hope it's still running here, right? So still green. And what I was going to show you is you can do stuff like this. If you wanted to only use a particular dependency in one test method, you have this kind of cool feature with JUnit 5 and Spring 5. So here you can auto-wire in, for example, something you can use at qualifier. You can use at value through execute spell expressions, pass in the web application context, etc. So I think I'm running out of time, but you kind of get the gist. Straightforward. You get all of the core features from Spring testing support with JUnit 5 already. So in closing, what's missing? Official IDE and build integration support. So again, we hope that's going to come from the respective parties over time, especially now that we're going to have an M1 coming out soon. Dynamic tests. So for example, registering tests as lambdas, as streams, collections, this kind of stuff, instead of having just your static methods that you've compiled in. Parameterized tests, somewhat analogous to what you already had in JUnit 4. We were looking forward to having something like that in JUnit 5 as well. Constructor injection, something we're thinking about, like the method injection, but giving extension implementers the ability to inject parameters into constructors, for example, like Spring or Juice. Scenario tests, so that's something you might be familiar with TestEngine. You might not know it, but with JUnit 4, your test class is instantiated every time a test method is executed. But sometimes you'd like to retain state. Maybe you're going through certain steps in an algorithm, like logging into a website, doing something, filling out a form, submitting the form, seeing what happens when there's an error, logging out, right? So this would be kind of a stateful set of steps you'd group together. We call that scenario tests, and we look to support that before 5.0 final as well. Some more advanced things like maybe parallel execution or executing tests in different threads, things we're thinking about as well. Anything else? If you want to give it a try and let us know. If something's missing, we would really appreciate that. And speaking of which, so resources and feedback channels. Just start with JUnit.org and then /JUnit 5. You get links to the reference manual, the Java doc, the issues, etc. User guides online, Java docs online. You can find us on GitHub for pull requests, submitting bug reports, etc. And we also have a few sample projects that basically just show you how to set up your Gradle build file or your Maven POM in order to get your JUnit 5 tests running with your build. We're also on Twitter and Stack Overflow. We have a tag. There are currently only 2 questions there, but we expect that number might increase over time. So just stick around for a few more minutes. I think it's officially over until they kick us out. But thanks for coming, and I'm around if you have questions.